Hi everyone. So in this video, I'm going to go over a similar problem that we went in class, and we're going to see how probability theory is going to help us not succumb to the base rate neglect fallacy. So if you just read this without knowledge of probabilities, which we now have, if you just read this, you might think that after getting a positive test result, your probability of having a disease is really, really high. And you'll see that it might not be as high as you think. And now I'm going to go through the example carefully. That way you have a reference point to work through. But before I start, I really recommend you to pause the video, to write it down, and to work on it on your own, and then just look at the video when you need help or to check your answer. And if you don't know where to begin, you can start, and then once I give you the ingredients, I would pause the video and again try to do it on your own. Okay, so let's start. So suppose we have a pretty reliable test used to diagnose a disease. So 97% of people with the disease will get the positive test result, and 95% of healthy people will test negative. And suppose that the prevalence of the disease in the population, which we also call the base rate, is 1 over 100. So how likely is it that a random person who gets a positive test result actually has the disease? So let's look. So what do we want to find out? A good step to start is how likely is it that a random person who gets a positive test result actually has the disease? So how do we write that in terms of probability? Well, first we have to kind of write out those statements. So let's write the symbol plus to mean you test positive. The symbol minus means that you test negative. And say that D means that you have disease. Have the disease. And of course, not D means you don't have the disease, so you're healthy. We have all your ingredients now. So note that actually test negative is just not test positive, but it's nicer to see a plus and a minus instead of not plus. So what do we care about? What we care about is figuring out, well, given that I test positive, how likely am I to actually have the disease? That's what we care about. So how we write that down is the probability that we have the disease. Really, we care about our health, right? Given that we test positive. Okay, so what is that? That's what we're going to try to find out. And step 2, you might ask, well, what do we know? So what we know over here is that 97% of people with the disease will get a positive result. So what does that tell us? That tells us that the probability that you test positive, given that we know you're sick, that you have the disease, is equal to 0.97. What we also know is that the probability of testing negative, given that you do not have the disease, meaning that you're positive, is 0.95. So are we done with what we know? No, right? Because there's one thing left, which is the probability we call the unconditional probability of just any random person having the disease, and that is 1 in 100. Okay, so now we actually have all the ingredients necessary. So let's show it. I will move this down a bit to make it a little bit cleaner. So I'll make this thinner. Okay, so let's start. Let's try to expand this. Okay, probability of that you have the disease given that you test positive. How can I expand this? Well, by the definition, right? By the definition of conditional probability, you can write what? You can write that the probability that you have the disease and you test positive over the probability that you test positive. Okay, seems simple enough. So now what we need to know is the top part and the bottom part. Do we have it over here? Well, not immediately, but if we do some work, we do. right? Because if you note that this over here, by again, the definition of conditional probability is what? Well, it's a probability that you test positive and you have the disease over the probability that you have the disease. Now note that this part over here is exactly what we want, right? Because, well, we switched around, but actually they're the same, right? Probability of having the disease and testing positive is equal to the probability of testing positive and having the disease. So we have that. Right? So what we can say is we multiply both sides with probability of D, and we actually know what the probability of D is, right? It's 1 over 100, and that gives us the probability that you test positive and that you have the disease. So it's 0.97 over 1 over 100, right, is equal to the probability that you test positive and you have the disease. Okay, so let's write that at the top, right? So you have, well, 0.97 is 97 over 100, just not to make any mistakes, times 1 over 100 over the probability of testing positive. Okay, so it looks like we're almost done. But finding the probability of testing positive requires a little bit of work. So let's do the work. Okay, so the probability of testing positive, note, by the law of total probability, so you can do this by law of total probability, so I'll let you a second to think what it will be. Well, it's just a probability that you test positive and you have the disease, plus the probability that you test positive and you do not have the disease and you're healthy. Right? And so actually this part over here, we already know what it is, right? It's over here. We already did this. Probability you test positive and have the disease is just 0.97 over 100, or 97 over 100 times 1 over 100. So we actually have this part. Okay, so right over here, we have probability that you test positive, and we can actually just write, well, this is just, let me make this a bit cleaner. So this is actually 97 over 100 times 1 over 100 plus the probability that you test positive and you do not have the disease. Right? How do we get this? Well, this is just from over here, right? So now what we're going to figure out is this person over here. The probability of testing positive and not having the disease. And once we get that, then we're done. Okay, so let's clear up some space. I'll erase this over here. If you need to just rewind the video. Okay, so what is the probability of testing positive and not having the disease? How are we going to find that out? Well, note one thing, that actually we haven't used this over here, the probability of testing negative, given that you don't have the disease. So this might be a good hint that you're going to have to use it. Well, let's expand it again by the definition of conditional probability. So what do you get? You get that the probability of testing negative and not having the disease over the probability of not having the disease is equal to 0.95. Okay, so now what do we do? Well, note that we just multiply both sides by probability of not having the disease. And what is this? What is the probability of not having the disease? Well, we didn't have this at the start of the example, but by rule 1 and 4 that I gave you, you can find it out, right? Because actually we even derived it in class, the probability of not having the disease is equal to 1 minus the probability of having the disease, which is 1 minus 1 over 100, so it's 99 over 100. Right? Because we derived this in class. So the probability of having the disease or not having the disease is equal to 1, right? That's just a tautology. And they're mutually exclusive, so you can separate it out. And we know what the probability of having the disease is. It's 1 over 100. So the probability of not having disease is 99 over 100. And so this implies that we have 0.95, which is 95 over 100, over 99 over 100 is equal to the probability of testing negative and not having the disease. Okay, so, okay, but that's still not what we want. We have the probability of testing negative and not having the disease. But what we really want to finish this problem is a probability of testing positive and not having the disease. Okay, so how do we figure that out? So let me just write this a little bit nicer. I'm going to erase this part just to make some space. So 95 over 100. And I'm keeping all these fractions intact because that way if you make a mistake in calculations, and I'm known to make these mistakes in calculation, you won't, you can still get credit for the problem. It also shows your thought process. So what we found was the probability of testing negative and not having the disease. This is what this was. What we actually want is this. Okay, so let's look at these two. Okay, how can we put them together to find out what this is for what the probability of testing positive and not having disease is? What we're going to have to do is put them together. We know that if we add these two and not having the disease, if we add them, what do we get? Well, we know that this is equal to 1, actually. Sorry, not to 1, to the probability of not having the disease, right? And this is by the law of total probability. Right? Probability of not D is equal to probability of not D and something plus the probability of not D and not that thing. And here it's testing positive and testing negative. And now we can figure out what this is, because this is what we care about, because we know what this is and we know what this is. Namely, we know that the probability of testing positive and not having the disease plus 95 over 100 times 99 over 100 is equal to the probability of not having a disease, which is 99 over 100. Okay, so now I will erase this just to make space. And so we subtract this part and bring it to the other side, and we get that the probability of testing positive and not having the disease is equal to 99 over 100 minus, right, 95. Right, this is actually minus, it's not testing negative. 95 over 100 times 99 over 100. And now we have what we want over here, right? So let me erase again and make space, and we're done over here. And I will actually let you, as an exercise, to calculate this. That way, you can check if you're right. I will let you calculate the exact value of this, but we've done all the hard work. So we know that the probability of having the disease, we'll just put in, this is a long equal sign, is equal to 97 over, well, 100 times 100 is 10,000. over, well, 97 over 10,000 again, plus, well, the thing we found out here, which is 99 over 100 minus 95 times 99 over 10,000. And we're done. So I'm going to let you calculate what exactly it is so you can be surprised. But that was our derivation. Good. I hope this helped. And again, as usual, if you have any questions, please come to office hours or send me an email, and I'm happy to help. So thanks for watching.